This film has been produced by the Sporting Arms and Ammunition Manufacturers Institute. The Institute, commonly referred to as SAAMI, is a trade association composed of the major manufacturers of sporting arms and ammunition in the United States. This film identifies the characteristics of sporting ammunition when exposed to severe impact and to fire. This film will demonstrate how sporting ammunition fires may be safely and effectively extinguished by firefighters using standard fog nozzles and protected by standard firefighting turnout gear, including face shields or self-contained breathing apparatus masks. This fire service training film has been prepared by SAAMI to assist firefighters in their understanding of sporting ammunition when exposed to fire. We gratefully extend appreciation to the IAFC, Chief Warren Isman, Chairman of the Hazardous Materials Committee, and representatives of the transportation industry and fire service for their suggestions in developing the firefighter scenes shown in this film. In the North American continent alone, billions of cartridges and shot shells are used annually by sportsmen and hunters. There are more than 450 different types of sporting ammunition products used by the recreational hunter. This volume of sporting ammunition means that it is possible for firefighters to encounter sporting ammunition in transportation fires, as well as fires involving warehouses and various types of retail locations. The producers of sporting ammunition believe it is important for firefighters to know what to expect when sporting ammunition is encountered in the hostile environment of a fire. Sporting ammunition does not include tear gas cartridges, tracers, bulk propellants, or large caliber military ordnance. This film is confined to sporting ammunition only. There are two principal lessons to be learned from this film. When sporting ammunition is involved in a fire or subjected to severe impact, it will not mass detonate. And second, there is no danger of being shot. The following scenes were taken from a previous SAAMI film designed to show the resistance of sporting ammunition to severe shock and fire. These tests were conducted in 1974 in cooperation with the Chicago, Illinois Fire Prevention Bureau. The first test conducted was to determine the effect of impact upon sporting ammunition. 3 cases of ammunition were loaded into a clamshell bucket of a crane, hoisted to a height of 30 feet, and then dropped onto the pavement below. The impact on the concrete broke open the packing cases, causing some of the contents to scatter. No cartridges fired. A much more severe experiment was conducted by shooting high-power rifle bullets into cases of ammunition. 3 types of ammunition were used. 1 case of center-fire rifle cartridges, a second contained shot shells, and a third case contained 22 long rifle rimfire cartridges. Each of these 3 cases was fired at using .308 Winchester caliber 150 grain soft point ammunition fired at a range of 35 yards. Each of the 3 cases were shot at least twice. In each instance, there was damage to the packing cases themselves and to the contents of the cases. In some instances, a few cartridges or shot shells fired within the packing carton because of the high impact from the bullet fired at them. But in no instance was there any evidence of mass propagation or explosion of the cases containing these cartridges and shot shells. In these tests, a shot shell and a center-fire rifle cartridge were mounted in firearm receivers. The box enclosure you see is a pasteboard type of box in which the product is normally packaged and retailed. Without the confinement of a firearm chamber, little if any pressure is generated by the burning powder. The slow motion camera shows you that the shot from the shot shell will not penetrate the cardboard enclosure. Equally impressive is the demonstration of the high-power rifle cartridge. Again, without the benefit of a firearm chamber, the bullet merely tumbles through space and does not penetrate the pasteboard box. The reason for the low velocity of these projectiles is that smokeless powders must be confined in order to develop the pressures required to propel the projectile at high velocity. When cases of ammunition are involved in a fire, the powder in the product will not cause the shot or bullet to propel at a velocity which would cause danger to a firefighter wearing full turnout gear and face shield. A concrete block structure 6 feet by 6 feet was constructed. A heavy steel mesh grill was supported off the bottom of the structure by concrete blocks. The cased ammunition was stacked on the steel grill. Oil-soaked scrap lumber stacked beneath the grill provided a hot fire for positive ignition. 1/4-inch thick, flat boiler plate was placed on top of the structure to complete the confinement. The cartridges started popping about 3 minutes after ignition and continued a steady popping for about 36 minutes. Dense gray smoke curled out of the structure. Puffs of smoke were observed from time to time, due possibly to the combustion of combustible gases above the fire in this relatively tight structure. The gases were produced because insufficient air was provided to support complete oxidation of the combustibles. Some missiles were projected through an opening at the bottom of the structure. The heat of this fire was so intense that the grill collapsed and several small cracks developed in the mortar joints between the concrete blocks. The molten lead deposit found in the bottom of the enclosure gives some indication of the heat that developed during this experiment. Mass detonation did not occur. Ammunition for this scenario was stacked inside the building near the left corner on a wooden platform. A large quantity of scrap lumber and fiberboard packing material was piled adjacent to and under the ammunition. Fuel oil was poured over some of the scrap lumber, and the fire initiated by an electric squib. An abandoned manufacturing building, which was scheduled for demolition, was used in this experiment. The building was a solidly built frame structure, 20 feet by 20 feet, 1 1/2 stories high on a concrete pad. It had wood sheathing with a tar paper exterior and a steeply pitched asphalt shingled roof. There were 14 3-foot by 6-foot wooden sash glass windows and a 15-foot ceiling. Sounds of the ammunition popping began approximately 1 minute after ignition. Popcorn popping effect lasted for 20 minutes, at which time the building was completely involved. Fire personnel at the scene were members of the Olin Fire Protection Department. They were spraying the adjacent trees behind the building from a distance of approximately 35 feet to prevent the fire from spreading to the timbered area. Firefighting personnel were as close to the building as the heat would allow during the height of the fire. They encountered no problems from any missiles from the burning ammunition. Their personal protective equipment included standard firefighter turnout gear and plastic face shields that extended from their helmets. This test indicates, again, that there is no mass detonation of sporting ammunition when involved in a fire, nor do the projectiles from burning ammunition in an unconfined area achieve the velocity that one would encounter when a projectile is fired from a firearm. While the tests that we have just shown you amply demonstrate the characteristics of sporting ammunition when subjected to impact or when involved in a fire, the Sporting Arms and Ammunition Manufacturers Institute wanted to develop techniques which could be shown to firefighters for use in the confinement and extinguishment of such fires. They consulted with representatives of the International Association of Fire Chiefs. Based upon recommendations received from the IAFC, the following demonstration scenarios were developed. In this scenario, over 53,000 rounds of ammunition were used. If one were to combine all of the powder contained in those rounds of ammunition, it would weigh 73.3 pounds. This turnout gear, including an Nomex coat, was placed about 10 feet from the burning ammunition to determine what type of penetration could be expected from any projectiles. The purpose of this scenario is to demonstrate that a free burning or stage 2 fire involving sporting ammunition can be easily extinguished by simply cooling the ordinary combustibles such as cardboard, wood, or other articles adjacent to the sporting ammunition below their ignition temperatures. Sporting ammunition will not support its own combustion. The popcorn popping sound from burning sporting ammunition will stop when the ordinary combustibles around the ammunition are cooled below ignition temperature. The heat developed from this fire, basically caused by the ordinary combustibles used, resulted in a char depth of 1/2 inch in the 2-inch by 12-inch roof joists. The smoke developed from the burning propellant does not give off explosive fumes. There is a significant quantity of smoke produced by the plastic from shot shells and the propellant used in cartridges and shot shells. Accordingly, ventilation ratios greater than for normal structure fires should be used. Firefighters from the Fridley, Minnesota Fire Department and the Assistant Chief of the Andover, Minnesota Fire Department participated in the fire attack scenes. They encountered no difficulty in extinguishing any of the fires. They were protected by full turnout gear, including facial protection offered by their self-contained breathing apparatus masks. In addition, a 30 to 45 degree pattern on the 95-gallon per minute attack line fog nozzle stopped most, if not all, low-velocity metallic pieces from the burning ammunition. After ignition of the fire, the first popping sound occurred at 2 minutes 14 seconds. The fire attack commenced at exactly 4 minutes after ignition of the fire. The total time to extinguish the fire was 34 seconds. The pasteboard packaging had burned away during the intense fire, leaving large quantities of ammunition intact. This illustrates that ammunition will not, by itself, support its own combustion. The Nomex coat, which was exposed at close range to the ammunition fire, did not evidence any penetration from the metallic objects produced by the fire. Most sporting ammunition is shipped in the United States by truck trailer. For that reason, 3 types of trailer fires were developed using different attack procedures. The 3 tests involved the use of over 94,500 rounds of ammunition. In this trailer burn scenario, the mixture of sporting ammunition was loaded on pallets in the nose of the trailer. Ordinary combustibles were placed adjacent to the ammunition. The door to the trailer was closed 2 minutes after ignition of the ordinary combustibles. In this scenario, we have intentionally induced the breathing phenomena of a relatively confined fire. As the trailer is initially approached, the hotspot location in the trailer was found by spraying water on the side of the trailer and watching for the area of rapid steam generation. When the breathing condition and the color and volume of smoke is noticed by firefighters, the recommended attack procedure is to first ventilate the storage area from the highest point. This ventilation procedure allows the superheated gases to escape naturally. The roof sheeting of the trailer can be penetrated easily by a standard firefighter's axe. The next step is to apply a small quantity of water, which will be immediately converted to steam. The steam has two effects. First, it displaces much of the superheated gases which are ignitable, and secondly, it reduces the temperature on the inside of the container. The first popping sound from the ammunition was noted 6 minutes after ignition of the ordinary combustibles. The extinguishment process began 10 minutes after ignition time. After ventilation and application through the roof opening of a small quantity of water through a fog nozzle, the breathing condition was eliminated. The trailer loading door was then opened. Final extinguishment and overhaul was accomplished uneventfully by a direct attack on the fire. It is recognized that there are many departments which unfortunately are unable to provide to all of their members full protective gear, including face shields or self-contained breathing apparatus. If your department does not have breathing protection, this demonstration may be of help to you. The firefighters shown in this film are required by their departments to wear self-contained breathing apparatus for all types of fires. Because of the potential of low-velocity metallic fragments emanating from a burning ammunition fire, some measure of protection must be offered to the firefighter. In this scenario, we are showing that the skin of the trailer itself will offer significant protection to firefighters. The rear trailer door, which was shown in the preceding scenario, sustained some cable damage during that scenario. Therefore, the door had to be removed for the protection of the firefighters. Firefighters approached the fire at approximately a 45-degree angle to maximize protection offered by the sidewalls of the trailer. By bouncing the water streams off of the roof of the trailer and allowing the water to fall on the burning combustibles, the temperature is reduced below the ignition temperature of these combustibles. This application of water technique will also destroy the vertical heat column produced by most open or free-burning fires. The first popping sound from the burning ammunition occurred 5 minutes after ignition. Within 5 minutes, these firefighters began their extinguishment of the fire. Simulating the situation of firefighters without full protective gear, they have elected to utilize the holes near the roof on the sides of the trailer for application of water streams. A direct attack is now made on the fire through the rear opening of the trailer. By alternate use of straight and patterned streams, the firefighters are able to penetrate the pile of burning combustibles and easily extinguish the fire. The use of a wide fog pattern also assists greatly in the ventilation of the trailer. The total elapsed time from the start of extinguishment to the declaration of the fire being out was 4 minutes, using the technique shown here. Firefighters equipped with full protective gear, including facial protection, and using 1 1/2-inch hose lines and fog nozzles, can effectively and quickly extinguish sporting ammunition fires with the direct attack method. In this test, the first popping noise was noted 5 minutes after ignition of the fire. The extinguishment was commenced 15 minutes after ignition. The policy for the firefighters used in this demonstration requires the use of a backup line. Here the firefighters have their pattern set between 45 degrees and 60 degrees. That pattern will protect them from the possibility of low-velocity missiles being projected from the burning fire. As they approach the fire, the fog patterns can be reduced, allowing them to quickly cool the atmosphere below the ordinary combustible's ignition temperature. A straight stream pattern will allow the water to penetrate the burning rubble. The popping sound of the ammunition is quickly stopped, attesting to the burning combustibles now being cooler than their ignition temperature. The fire was declared out 2 minutes after extinguishment started. In this last burn scenario, we wish to re-emphasize the ability of the firefighter to directly attack the sporting ammunition fire. This scenario also illustrates the importance of full protective firefighting gear, including facial protection. The total powder weight of the cartridges and shot shells used in this test amounts to 99.8 pounds. There will be no mass detonation of the sporting ammunition. In addition, any projectiles emanating from this fire do not achieve the velocity or penetration capability that one would expect from the firing of a cartridge or shot shell from a firearm. Firefighters are amply protected with their turnout gear, including facial protection and their fog nozzles. The popping sound from the ammunition being burned by the ordinary combustibles begins soon after ignition of this free-burning fire. You will be able to observe the missile hazard, although minimal, which exists in burning sporting ammunition. The missiles of highest velocity will be the primer cups, but because of their poor aerodynamic shape and light weight, the primer cups lose velocity rapidly and are easily controlled by water from the fog nozzle. At very close distances, they could cause superficial flesh wounds to the firefighter if the firefighter were not protected with turnout gear and facial protection. The heavier projectiles, such as bullets or shot charges, and fragments from the cartridge cases, are not ejected from the ammunition fire at velocities sufficient to cause them to penetrate the firefighter's turnout gear. At an extremely close range to the fire, they will create a stinging sensation to the firefighter, unless the firefighter uses a patterned fog nozzle. Ammunition fires are noisy, generating the amplified sound of popping corn. Confronted by such sound levels, fire protection personnel understandably could be unnerved if they were not accurately informed of the nature of the fire being fought. As in the prior fire attack scenarios, the popping sound of the ammunition is quickly stopped as soon as the burning combustibles around the ammunition have been cooled below their ignition temperature. A total of 281,000 rounds of ammunition were used during the test conducted by the Fridley, Minnesota Fire Department. Despite the involvement of over 394 pounds of powder contained in these cartridges and shot shells, there was no mass detonation nor massive flame propagation from any of the fires. No firefighter sustained any injury during extinguishment of these fires. Each extinguishment evolution was easily and quickly accomplished by using 1.5-inch hose lines and 95-gallon-per-minute fog nozzles. Sporting ammunition in transportation, warehouses, and retail stores does not pose a fire hazard, nor do sporting ammunition stocks pose any significant dangers to the public or to firefighting personnel. Firefighting personnel must wear complete fire protective gear, including face shields or masks from self-contained breathing apparatus. If members of your department do not have full protective gear, including facial protection, then indirect application of water would be a recommended technique to reduce the temperature of the burning combustibles below their ignition temperature. At that point, a direct attack can be used for final extinguishment and overhaul. In summary, firefighters can safely extinguish fires involving sporting arms ammunition if the following rules are observed. Number 1. Full firefighter turnout gear, including face protection, should be worn by all personnel. Number 2. Water applied from standard fog nozzles with fire stream patterns of 45 degrees to 60 degrees will provide the nozzle man and backup nozzle man with protection from low-velocity metallic fragments. Number 3, if only limited personal protective gear is available to members of your department, then apply water by straight stream at the effective reach of the nozzle being used. If there are openings in the building or trailer through which water can be applied, use of the indirect water application method is recommended. Remember, the building wall or trailer skin provides a natural barrier for your personnel. Number 4, apply sufficient amounts of water to reduce the temperature of the ordinary combustibles below their ignition temperature. Full protective gear should be worn until overhaul has been completed. There may be hot spots in a fire involving ordinary combustibles until all of the material has been totally saturated. If there are hot spots and ammunition is present in them, they may cause the ammunition to pop. Superficial flesh wounds may be experienced on any unprotected skin area. Therefore, wear full protective gear and facial protection until the overhaul is completed. Number 5, when sporting ammunition is involved in a structural fire, ventilation openings or ratios should be increased. This is necessary to dissipate the additional smoke and any increased heat level generated from the ammunition being burned in the fire. The tests confirm sporting ammunition does not mass detonate when involved in a fire. Any projectiles are low velocity and do not present any significant hazard to firefighters wearing standard personal protective gear and face protection. The fires are readily extinguished by normal water application on the ordinary combustibles. Ammunition will not support in itself its own combustion. Inquiries concerning these tests may be directed to Chief R.D. Aldrich, Fridley Fire Department, 6431 University Avenue Northeast, Fridley, Minnesota 55432. Telephone area code 612-571-3450.